Hi everyone, welcome back from spring break. I hope you guys all had a wonderful spring break, whether or not you got out of town or if you just stuck around town and had a relaxing week off of school. Welcome back. We are moving into week 12 this week, and just a reminder to get us thinking to what we were doing before we started spring break. Remember, we were exploring everything about triangles, or not triangles, I meant to say circles. I was looking right at circles and I said triangles. Woo! Apparently I am adjusting from getting back from spring break as well. So waking that mind up, we were studying circles, and we're going to continue our exploration of circles this week as well. So at this time, I do want you to grab your math notebook if you haven't already, and we're going to start with a warm-up. We're going to get our minds thinking back to finding the distance between 2 points. So in this warm-up question, you are going to find the distance between point R that has the coordinates -3, 4, and the point S, which has the coordinates 2, 6. So you are going to find the distance between those 2 points. And I would like you to find the distance between those 2 points using the distance formula. So perhaps you've forgotten the distance formula, and that is okay because you have the internet available to you. So if you have forgotten the distance formula, what I want you to do is do a quick web search. If you type in distance formula, you're going to find a lot of resources appear in front of you. And something I like to do when I do a quick web search, if I use Google, is when I get my, I type in distance formula, and then underneath the search bar you're going to find images, and sometimes I just click on that images and you're going to find the distance formula given there in a lot of different formats. So something to play around with and try. If you don't like it, that's okay. Just thought I'd share that with you. So at this time, go ahead and click pause. Try to find the distance between these 2 points, and when you're ready to check your work with mine, go ahead and click play. All right, so what is the distance formula? So remember, when we calculate the distance between 2 points, so if we were to create a coordinate plane and plot our 2 points, we want to find the distance between our 2 points. We can use the distance formula. And the distance formula, what we're going to do is we're going to plug in our 2 coordinates. So this is our first coordinate right here, the R coordinate. I'm going to call this x1, and 4 would be my y1, my first y coordinate. Over here, this is my second point, so I would call this my second x coordinate, x2, which is 2, and then the number 6 here would be my second y coordinate. So I'm explaining that because the distance formula is the square root. And what we do is first we find the difference between our 2 x coordinates. So x2, the second x coordinate minus the first x coordinate. Then we square that value. Then we add to that the difference between our y coordinates. And since I took the second x coordinate first, I'm going to do the same thing over here and subtract it from my first y coordinate and square that. So it is okay if you want to use the distance formula where you're actually subtracting the x1 coordinate minus the x2 coordinate. That's okay. It's just important, whatever you do, whichever order you choose to do with your x coordinates, that then you do that same order with your y coordinates. So it doesn't matter if you subtract your x1 or your x2 first, as long as you do that same pattern with your y coordinates. So let's go ahead and find the difference, or I'm sorry, the distance between our 2 coordinates. So I'm going to go ahead and I'm going to subtract the x1 minus the x2 since that one's right on top here. So my x1 coordinate is -3. So I'm going to have -3 minus my y2, or I'm sorry, my x2, which is 2. I'm going to square that. Then I'll add to that, my first y coordinate is 4. And subtract from that my second y coordinate, which is 6. and square that. So let's start simplifying. -3 minus 2, that's -5. I'll square that in just a moment, and then I'm going to add to that 4 minus 2, which is -2. I'm going to square that. Then, what is -5 squared? -5 times -5 becomes +25. And -2 times -2, -2 squared, is 4. Add those together, and I get a total of 29, the square root of 29. Is that a perfect square? It is not. So I'm going to leave my answer as the square root of 29. That's going to be my most exact answer. The reason I'm going to leave that as the square root of 29 is because if I were to grab my calculator and type in square root of 29, I'm going to get a pretty long decimal. And eventually I would have to round that decimal. And anytime you round something, you're getting away from having the most exact answer. And that's okay sometimes when I ask you to round, but having the most exact answer would be just leaving it as the square root of 29. And that is the distance between point R and S, would be the square root of 29, which comes out to like 5.38516, blah, blah, blah. That's it. I'm going to go on to the next slide, so if you need more time here, go ahead and click pause. So this week, we are going to continue to explore circles. Oh, by the way, there's only 2 months left in the school year now. Kind of crazy, right? We've got April and May, and then we're done. So we are going to continue this week to study about circles. We are only going to do 2 sessions this week. I know some of you are still doing some state testing. So we're only going to do 2 sessions this week, and then I know a lot of you are going to be testing next week as well, so we'll also have a shorter workload next week as well. So I'm trying to help you guys out and lighten up our loads a little bit this week and next week, as well as we've got some students finishing up testing this week, and then some students will start testing next week. So this week we are going to be looking at segments both inside and outside of the circle, as well as we're going to learn how to write the equation of circles in a coordinate plane. So we know how, we've looked in algebra, we know how to write the equations of quadratics. Remember, that's x squared. We know how to write the equation for lines. And this week we're going to learn how to write the equation of circles. So let's jump right in. All right, so when we've got two chords inside a circle, so here's an example. Look at that, 2 chords. I've color coded them so that we can see a pattern that occurs here. So, but if you've got 2 chords that intersect inside a circle, then the products of the lengths of the segments of the circle are going to be equal. So what that means, if you take the distance, well, let's do from A to E. So if you take the distance from A to E and multiply it by the distance from E to B, guess what? They're going to be equal to if you do the same thing with the other chord. If you multiply the distance from C to E times E to D, those products, when we multiply those 2 together, those will be equal. And that's a pattern that we can use to help us find some unknowns. So take a look at this example down below. Here's 2 chords, right, that intersect in the middle of the circle at point E. So it breaks the chord up into 2 smaller segments. But look, we've got an unknown. We don't know the distance from C to E. And we know all the other distances though. So can we figure out the distance from C to E? We sure can, because we just learned about the chord product theorem that's going to allow us to set up an equation to solve for that missing length. So remember, if we were to take the distance from A to E and multiply it times the distance from E to B, that product is going to be equal to the distance from C to E times E to D. So I've split those up. So let's put in now the lengths that we're given. So from A to E, I know it's 6. EB is 5. We don't know CE, so I'm just going to leave that as CE. If we want to put that as X, you can. It doesn't matter. And then the length from E to D is 8. All right, so let's simplify. 6 times 5 is 30, and then we've got 8 times CE, or CE times 8. It doesn't matter which way you look at that. It's just important that we know they're multiplied. Those two terms are being multiplied, so when we go to solve for E, we know that we're dividing each side by 8. So what do we get then? CE is going to be equal to 30 over 8, which when we divide 30 by 8, we get 3.75. So CE is going to be equal to 30 over 8, or 3.75. And that is the chord-chord product theorem. So multiplying the portions of our segments and setting them equal to when we do that with the other chord as well. And that allows us to solve for some unknowns. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. I told you we're going to look at segments that exist outside a circle. So here we've got some segments that are both inside and outside. So when you have a secant, remember secant is a line that intersects our circle in two places. So when you've got two secants that intersect outside, so right here at point E, these two secants intersect outside of our circle, then the product of the lengths of one secant segment and the exterior of that secant segment is going to be equal to the other interior secant and exterior secant segment. So if you want to, another way I think about it is if you multiply the entire segment times the, and I meant to say, yeah, the entire segment times just the external segment, and you multiply that, the entire thing times the external segment, and that's going to be equal to the other entire secant segment, and then just the external. So here, looking at it, if you take AE, the length of AE, and multiply it times the length of BE, that's going to be equal to the length of CE times DE. So a way you could think of the secant product theorem is whole times outside equals whole times outside. Whole times outside equals whole times outside. That's the secant product theorem. So that always helps me remember what the pattern is for that. So looking down at this example where we can use this theorem to solve for an unknown. So look here, we've got two secants. They intersect our circle twice, and they intersect each other outside of their circle. So that means we can use the secant product theorem. So we are going to do the, well, before I get to what we're doing, let's look at what we're solving. So here, from J to H, I see an unknown. Uh-oh, that means there's something we've got to solve for. So the distance from J to H is what we're trying to solve for. All of our other segments are labeled with numbers, with lengths. We know from H to G is 13, K to G, the outside external portion here is 9, the internal is 30. And then we've got to find that unknown distance from the inside from J to H. So let's go ahead and set up our equation. So remember, we're going to take the whole, let's do this one down here first, the whole, the entire length, 30 plus 9, so 39 is the entire length, times just the outside length, which is 9. Then we're going to set it equal to the same thing over here. Uh-oh, but what is the entire length? I've got an unknown. That's okay. It's just going to be 13 plus z, that's the entire length. And then we'll multiply it times the outside, which is 13. All right, so let's go ahead and do the math on the left. 39 times 9 is 351 equals, I'm going to go ahead and leave this as is, 13 plus z times 13, because what I want to do is I want to start working on getting z all alone. So this entire 13 plus z, this entire amount is being multiplied by 13. So I'm going to get rid of that 13. I'm just going to divide it out on both sides right now. So 351 divided by 13 gives me 27 equals 13 plus z. And that's gone, right? That's canceled out. So now we're almost done. I just need to subtract 13 from both sides. And what do I get? 27 minus 13 is 14. So z is going to be equal to 14. So the problem asked us to solve for z, which we just did, and then the length of each secant segment. So then I could plug that in and add 14 plus 13 to get that entire length as well, which would be 27. So the length of JG would be 27. And we know the length from L to G is 39. So we did it. We used the secant product theorem to find the unknown. So that's what session 6 is all about, is looking at these different patterns that occur. So you're going to learn about some more with different segments. I'm going to not go over all those because I do want to get to the equation of circles. So you will have to do some investigation on your own to finish out session 6, and that's okay, but just got you familiar with types of patterns you're going to see. But I really wanted to introduce to you the equation of circles when we graph them in a coordinate plane, because this is an important concept. So if we have a coordinate plane, X and Y coordinate plane, and we draw a circle anywhere in that coordinate plane, we can write an equation to match that. So this is our general equation, or we refer to it as the standard form for a circle whose center, so if we were to find the center of this circle, it looks like it's somewhere right here. The center of the circle is going to have the coordinates HK. And that's important, that you know that the center of the circle is always represented by HK. So instead of X and Y, we're using HK so that we know that that is the center of our circle. So make sure you take this down in your notes right now. The center is always going to be at HK. That's what we use. Okay, because look at down here. Here's the general equation, or the standard form of a circle when it's graphed on a coordinate plane. It's always going to be x minus h, always going to be minus, squared, plus y minus k, always minus, squared, equals r squared. So again, h and k are going to represent your center. So in the general form, it's always minus. So in this case, the minus doesn't necessarily belong to the HK, the center. We're going to look at an example below here. And then R, so HK, remember, HK represents your center. And then R is going to be squared. So if you take the square root of whatever number is given after the equal sign, if you take the square root or look at it as R squared, R is going to represent the radius. So plain old R, without being squared, is the radius. So I know that this might seem weird, and I wanted to go over a couple examples to get you in the hang of pulling out and identifying the center and the radius when you're given the equation of a circle. So here's an equation of a circle. Instead of having h or k, it's actually got numbers in there. So look at this first example. X minus 5 squared plus y minus 3 squared equals 36. All right, so remember in the standard form, it's always x minus and y minus. So here's the h and here's your k. That represents the center. So what would be the center of this equation? What would be the center of this equation? Says we want to find the center. So remember, it's just h and k. So it's 5 and 3. So notice I did not say -5 or -3 because it already has, it's written, the standard form is x minus. So just the 5 and just the 3 represents your h and k, or your center. What about 36? That's going to help me figure out the radius. But remember, the radius is r squared. So what is the square root of 36? Well, 6 times 6 is 36. So just if I write it as 6, if I rewrite 36 as 6 squared, that helps me see that the r is just going to be 6. So the radius of this circle is going to be 6. So write this example down so that you are going to see problems just like that this week. And you're going to get some more practice with it as well. So looking at the second equation, this one's really important because we've got x plus 2 squared plus y minus 7 squared equals 49. So see if you can identify the center and the radius. This one's a little tricky because we've got a plus sign. My hint to you is remember that we can rewrite a plus sign as a double negative, and that might help you identify your center. That's my hint to you. So see if you can figure out the center and the radius of this second equation here. So if you want to go ahead and click pause, do so now. All right, so I needed to get this equation to match the standard form. And in the standard form, there's that minus sign. We're subtracting the x and the h value. So I needed to get this equation to also have a negative in there. So I just rewrote my plus sign as a double negative because we know plus is the same thing as having two negatives in a row. So in that case now, my center is going to be at -2 and 7. Remember that minus sign doesn't belong in front of that 7. That's just the part of the standard equation of y minus k. So in this case, your center of this circle is going to be at -2, 7. -2, +7. And the radius, well, we've got the equation equal to 49. Remember, if we take the square root of 49, because look up here, the equation is always given as r squared. So if you take the square root, you're going to get 7, which means the radius is 7. So it's really important that we understand the general formula or the standard equation, standard form of our equation. We write this down in our math notebooks, and we know that it's always given as x minus and y minus. So that means finding the center, which is always h and k, and there they are located in the equation, paying attention to the plus and minuses in front of them. So it's kind of opposite of what you think it should be, right? Finding the center is opposite of what we think it should be. Here we've got a +2 and a -7, and the center then becomes at -2 and +7. It's opposite of what we think the sign, or opposite of what the sign is in front of it. Opposite of what the sign is in front of it. So we can also write equations. If we're given the center and the radius of a circle, we can then turn around and write the equation of our circle. So we're going to do this at one time and then we're going to stop. We're going to be done. So here it says, what is the equation of a circle that has the center right here at 4, 6? The coordinates of the center would be at 4, 6. And then out from that center, if we go in 4 units, that's the radius. So how would we write the equation of that circle? So if you want to try this, if you think you can do it, go ahead and click pause and try it first. I'm going to do it and show you how it's done in just a moment here. So if you want to click pause first and try it on your own, go for it. All right, so the equation, all I'm going to do is, I know that the center is HK. So that means that the H is going to be 4 and the K value is going to be 6. And then the R value is going to be 4 when I go and plug that into the equation. So I'm just going to go up here and write it underneath the equation up here since I've got that already written out. So I'm going to start with x always stays as x minus, I substitute in the value for h. So that's my x coordinate of my center, right? And then I square it. Then I come over here and I say y minus, what's my k value? It is 6, and then I'm going to square it, and then I'm going to also square r. So 4 squared is 16, and that's my equation. That's my equation. So again, remember that with the general standard form of the circle equation, you only substitute in numbers for h and k and r. You're going to put numbers in there. X and y will stay just as x and y. So you only substitute in values for your center, which is h and k, as well as the radius. Everything else stays x and y. All right, so that's it. I'm going to go ahead and you guys are also going to learn how to graph circles, given equations. I think you'll find that easier once you understand the equation of circles, which we just went over. All right, so one of the things we learned about today was the equation of circles and coordinate planes. And here's the equation of a circle. X minus 4 squared plus y minus 2 squared equals 25. I want you, from that equation, to tell me the coordinates of the center of that circle, as well as the radius of that circle. And that's it. Have a wonderful week. If you need any help with anything this week, let me know.